algebraic proofs. So these are just some properties that you use all the time in Algebra 1, but we've just never written it out in a sentence format. So the first one here, addition property. Again, something you've done often, but probably just haven't looked at it from this standpoint. So if A equals B, we know that we can add something to each side of the equation and it doesn't change the equation. So if you did A plus C would equal B plus C. We do this often with solving. We add something to the other side to solve. So we know adding to both sides is common. We also know you can subtract things on both sides of an equation and it doesn't change the value of the equation. Same thing with multiplying. As long as these two things are equal, you can multiply both sides of an equation by something. A times C is the same as B times C. And division, again, we just use this in solving. A lot of times we show that, oh, I can divide C to the other side. If you divide both sides, it doesn't change the actual value of the problem. These are either called properties of equalities because these all have equal signs in those. Okay, and that's what POE stands for, is property of equality. POE, property of equality, they have equal signs involved in those problems. Distributed property is another property you learn in middle school at some point. If you have A times B plus C with the parentheses, we learn distribute means to multiply the A times the B and then the A times the C. So I'm going to write it out with letters, but obviously if it was numbers, I would multiply A times B and A times C. Substitution is something else you do a lot in middle school. If I tell you if A equals B, then you can replace, then A can, I'll put little quotes around that, then the letter A can be replaced with the quote, the letter B. If A equals B, then you can substitute in, wherever there's an A, you can plug in the B. We did that with systems of equations. We got like x equals 5, so we plugged back in the 5 wherever there's an x. Reflexive property is one that you don't use very often, and we won't use it much this chapter, but we're definitely going to use it in the upcoming chapters. But I wanted to give you one location with all the properties. Reflexive property is when, let's say A equals A. It's when something equals itself. Again, we don't use this much in like this chapter, other just in identifying it, but it is used in our following chapters. So, symmetric property. You know, symmetrical means like if you look in, fold something in half, it's the same on both sides. So if A equals B, then we can say B equals A. So if I fold this paper in half over the letter then, the word then, the B and the A would line up and so forth. So it's just symmetrical, it's the flipped version of something. Transitive property includes 3 different things. So if A equals B and B equals C, then basically if A and C both equal B, then we know that A should equal C. That's called transitive property. Some people get that switched up with substitution because you could substitute the A in place of the B here, and that's how we get A equals C. But transitive property is when 2 things equal the same thing, therefore those 2 things are equal. Alright, so in a 2-column proof, in our district we're doing proofs in 2 columns. The left side is called the statements. Or steps. Some people think that's where all your math goes, is on the left side. And then on the right side is your reasons. Like, why do you justify each step? So tell me why you did that. Was it a property? What happened? Was it a definition? So what can be used as reasons? You can have any of the properties listed above. We can use any definition that we've used so far, or any definitions you may know. Definitions could be like the definition of perpendicular lines are equal 90 degrees. You could use the definition of an angle bisector means that two angles are equal. So any definitions that we've had. Postulate. Some postulates we've talked about is segment addition postulate or angle addition postulate. And then any theorems. I'm trying to think. One, obviously, that stood out that you might have heard from middle school was Pythagorean theorem, that a squared plus b squared equals c squared. There's other theorems that we'll get to, but these are just kind of what will go on the reasons side of your problem. So all proofs start off the same way. You start with what's given. So this is what's given. This is the equation that we start with. So step 1 is always to write down the given problem. That is always true. Now in these other boxes, we're just going to work on solving. The difference between the way you solve in a proof and the way you solve just on a piece of paper, some people would prefer to write it out on paper because if you're someone that likes to show work, and you're used to, say, writing -4, and then showing that step, you may want to do your problems on another piece of paper. In the proof, what I did was I subtracted 4 to the other side because I'm solving for x, because it says we want to prove x equals -5. So I would write on line 2, 3x equals -15. And what I did to get to that step, from step 1 to step 2, is I used the subtraction property. And I'll write POE, subtraction property of equality, because I just subtracted that to the other side. Then, the last step to solve would be to division. Again, if you want to show your work somewhere else, that's fine, because I don't write that in the proof. What I write in the proof is, when I divided, I got -5. So, step 3, I used the division property. So on the left-hand side, you have your statements, do your math. On the right-hand side, you're giving me the reasons, or what did you do on each step, like writing it out. One thing to always remember, the top line is always your given, and the bottom line here is always what you're trying to prove. Now you don't put the word prove here. You put, this is what we did, and these were the steps I did to prove that answer was correct. Okay? So we're just doing algebra to start with because we want to make sure that you understand just the concept of a proof before we get into some more related to our angles and segments and things. So here's a larger algebra question. We start with our given. We'll write down the problem. This whole thing is given, so this whole thing is your problem. You can kind of choose, just like any other time, how you want to solve your equations. You just need to justify on the right-hand side, what did you do on that step. All of us should, though, start this one off with distributing to get rid of our parentheses. So you get 6x minus 24 plus 2x equals x plus 4. It's called distributive property. And now kind of here is like it's totally up to you. That's why we didn't give you boxes here. You can decide how you want to solve your equations. I do want you to notice I put step 1. I put 1 over here was given. So step 2, this is what I had, this is what I did. Make sure if your math gets sloppy, that's why we number these so I can follow this was your step 2 and this is your reason you got to step 2. Okay. I'm going to do the 6x plus 2x and write 8x minus 24 equals x plus 4. You can do this 2 different ways. You can call it combine like terms. That's what I did. I combined my like terms. Because that's what I usually call it. Some people, like some textbooks, just wrote simplify. It's another way you can look at that. So either way, you can call it combining like terms, or you can just call it simplifying. We simplify the problem before we're going to move anything. Step 4, I'm going to subtract my x to the other side. I'm going to call that subtraction. And this is where there's leeway. Which way do you want to move? The numbers first or the letters first, it doesn't matter. One thing I do want you to notice though, if you notice your answer up here, it says x equals 4, so the x is on the left-hand side. You want to try and make sure when you're solving it, when you get down here at the end, we want the x on the left. Okay. Next step, I would add 24 to the other side and get 28. We'll call that addition. And then my last step would be division, because I'm dividing by 7, and I get 4. And POE just stands for property of equality, because all these things I was doing was related to this is an equal sign and I'm trying to solve. So, again, key factors. The given needs to be on the first line. What you are trying to prove needs to be the last line of your proof. If what you solve and you get isn't what you're trying to prove, then you've made a mistake in your work somewhere. Okay? Alright. If I were you, I'd pause the video at this point, try this one on your own, see how you can do. Choose what you're going to do. I always distribute first to get rid of parentheses, if there's parentheses. So you can either write this 3 times 6 would be 18. You could write it as 18 over 4 if you want to leave it in a fraction form. You could leave it in a decimal form. However you want to distribute this. Comes out if you want it in decimal, that would be 4.5. If you want to leave it a fraction, you can call that 4.5. So I distribute it. Okay, I think I'm going to subtract my y's now. I'm going to subtract 3/4. I'm going to do minus 1/2. 3/4 minus 1/2 is 1/4. Then I'm going to choose to add my 4.5 to the other side, or 4.5 if you want to make it a decimal. That'll give me 7.5 on this side. I call that addition. I added it to the other side. And the last step is division. I wrote it as division. In this case, if you want to call it multiplication, if you want to just times 4 to the other side, I would accept either answer on this one. So I'm going to take out my calculator, 7.5 divided by 1/4, and I come out to the answer of 30. I always like to double check just to make sure. This is question or statement 5. I'm going to say division. Because on my calculator I did 7.5 divided by 1/4 to get my y equals 30. double check. Did we start off with our given in the first line? Oops, sorry. That's my given. This is what it asked me to prove. When I got done, I have the correct answer at the bottom, so I know I've done it right. So just a little bit of what a proof looks like. The left-hand side, the statements are going to be your math or what we're doing to solve. The right-hand side is like your reasons. Why did you do each step in the process?